So our 2024 DEB mock option A question 9 uses our coordinate geometry stuff. So remember, as soon as we are seeing this coordinate plane, we are looking at coordinate geometry and we're opening up that page in our log tables. So as soon as you see anything to do with coordinates and coordinate planes, you are opening up your log tables on page 18. Okay, so it says a park in the shape of a parallelogram ABCD is being constructed as part of a new town plan. The map of the park is partially constructed with points ABC shown in the diagram. So the only thing there that might be important for me is that ABCD is a parallelogram. So part A says write the coordinates of the points A, B and C in the spaces below. So remember for this, we write our x coordinate first. So where does it line up with on the x axis? Okay, remember the x coordinate always goes first, x then y, so they go in alphabetical order. So for A, my x coordinate there is a -1, and then my y coordinate, go across to the y-axis, is 3. Okay, so if you didn't get that, maybe pause the video now and try for B and C again. Okay, for B, the x coordinate, so on the x-axis, it lines up with -3. And then the y coordinate, so where it lines up with on the y-axis, is also -3. Okay, and then C, on the x-axis, it matches up with the number 7. And on the y-axis, it's straight across from B, so it has the same y coordinate, a -3. Okay, so then it says complete the parallelogram to show the point D. Write down the coordinates of D. So there's loads of different ways we can do this. Okay, you know the properties of a parallelogram. The two opposite sides have to be the same length and they need to be parallel. So if you wanted, you could say, okay, well, what is the distance from B to C? Just count up the boxes. Okay, so we have 10 boxes between B and C, and that's a perfect horizontal line. So from A, I could do a horizontal line across 10 boxes. Okay, so that's one way of doing it, and I could find that that must be where D is, and then just connect that other line up. Okay, likewise, I could say, okay, well, it must be a line parallel to this and a line parallel to this. So I could continue from A on, and I could continue up in a slope the same as this one. So it goes up 3 across 1. So I could go up 3 across 1, up 3 across 1. Okay, and then see where those lines intersect. So there. Okay, so there's loads of different ways of going about this. Okay, way more ways. Whichever way you've done is absolutely fine, as long as you found that D is that point there, 9, 3. Okay, so D is 9, 3. Don't forget to write it in there. Now, part C, and don't forget to finish, even after you've found the coordinates of D, don't forget to finish drawing the parallelogram. Okay, so if you've done it like I did as a line from A crossways and counted up 10 boxes, don't forget to connect up those two lines. Otherwise, you have not completed the parallelogram. Okay, part C then says, a fountain is to be built at the midpoint between the points A and C. Write down the coordinates of the fountain. Now, there's a few different ways of doing this. Okay, one way of doing this is we know a property of our parallelograms is that if we were to connect up the diagonals, that they intersect and they bisect each other. So that means that if the diagonals bisect each other, then this point here where they bisect each other has to be a midpoint of the line segment A to C. Okay, So that is one way we could have done it. Okay, this obviously, the midpoint thing could come up without that. So we do need to know how to use the midpoint formula. So in our log tables, when you go to page 18, you find the word midpoint and use the formula across from that. Okay, it is written down as a point. So the formula, remember, your points look like this. Okay, an x coordinate and a y coordinate with brackets each side and a comma in the middle. That is what your final answer should look like. You should have something here and something here. Okay, so you're not using that comma in place of a multiplication or joining those numbers together in any way. Okay, you are doing the work within the brackets, but you are keeping the brackets there. Okay, so this is our midpoint formula. We need to use x1, x2, y1, y2. So we are finding the midpoint of the points A and C. Make sure you use the correct points. Okay, A is -1, 3. C is 7, -3. Okay, so it's very important you're using the correct points here. Once you have the points written, look at one of the points and ask yourself, what is that point actually telling you? So that point A, -1, 3, is giving you an x coordinate and a y coordinate. Okay, C over the other side is also giving you an x coordinate and a y coordinate. Okay, so once you have decided that, then call one of the points x1, y1 and the other one x2, y2. Okay, otherwise, I've seen people try it before where they say x1, x2 is the first point and then it gets all muddled up and you're not getting the marks that you deserve here. Okay, so fill in your formula there. So fill in x1 and x2 and likewise y1, y2. So x1 was -1, x2 was 7, y1 is 3, and y2 is a -3. Okay, so that means that in my brackets, okay, I am going to end up with, on the top line, when we simplify it, 6 and 0. So that means I have, again, I'm keeping the open brackets and the comma. 6 divided by 2, I'm going to get 3. 0 divided by 2, I'm getting 0. Okay, it has asked me for the coordinates of the midpoint. So my answer should look like a point. This is what a point looks like. Okay, open bracket, the x coordinate, comma, the y coordinate, close brackets. Okay, part D then says a fence is to be built around the perimeter of the park. Find the distance from A to B and hence work out the length of the fence in the diagram. Give your answer in centimetres, correct to 2 decimal places. So we have to find the distance from A to B. A few different ways we can do this. Okay, so you can, if I try and just neaten this up somehow. Okay, one way I could have done it is if I say, okay, well, look, if I drop down from A, I have a right angled triangle here, so I can use the theorem of Pythagoras to find out what that length would be if I treat this as a length 6 and this as a length 2. So that's one way I could do it. The other way I could do it, seeing as my log tables are already open on page 18, okay, you can see that there is a distance formula, okay, and it's given with lines on each side, okay. It's not actually called a distance formula, it's called a length formula, but those lines on each side of the letters are the same. So in your log tables, it's given as P and Q with lines on each side. Okay, and it's given as the square root of x2 minus x1 squared plus y2 minus y1. Okay, and make sure you don't do it I just done. Squared. Okay, that square root needs to be over the full thing. So if we are getting the distance from A to B, well, A is my coordinates -1, 3, and B is -3, -3. Okay, so just focusing on these, I am going to call this x1, y1, and then I'll call my coordinates from B, x2, y2. So I have to relabel them, even though down here I had x2, y2 labeled as other things. Okay, just focus each time on whatever points you're using in that particular question and relabel those points that you're using in the particular question as x1, y1 and x2, y2. Okay, so now I will be able to fill in my formula. I'm going to fill it in black just so that it's really clear. So it's x2, so a -3 minus x1, so a -1, all to be squared. Okay, plus I'm actually going to, I know I just said I'm going to write this in black, but I'm actually going to fill some of that stuff in blue, just again, because I have multiple operations going on, to make it really clear. So I have a -1 there. Okay, so if it is getting confusing with things, you can use different colours, especially when you're doing your own revision. Okay, then likewise here, I'm going to have a y2 minus y1, so a -3 minus a 3 to be squared. Okay, so simplify inside those brackets. -3 minus a -1. So what happens with the minus acting on the -1? Well, it's multiplying it, so it's going to become a +1. So it's -3 plus 1. So it's a -2 squared. And then -3 minus 3 is going to become -6 squared. Okay, so when I do that out, I'm going to get the square root of 4 plus 36. So I'll get the square root of 40. Okay, and it does say correct to 2 decimal places. Don't round it right yet, okay? Just leave it as the square root of 40. Okay, once you get to the end part, so once you get the full perimeter, then round it. Okay, so I'm going to just continue my work down here. Okay, I'm going to make a note that I'm doing that to the examiner. So I'm going to say continue on back page is where we'd usually continue our work. So continue at back. Okay, so this is question 9D. Continued. I need to find the full perimeter still. Okay, so that length square root 40 from here to here is the same as the length opposite it. So I have another square root 40 there. And then I have this side 10 and this side 10. Okay, so I need to add all of those up together. So I have that the perimeter is square root 40 times 2 plus 10 by 2. Okay, that is the perimeter of the full parallelogram. When I add all that up and put it into my calculator, I'm going to get 32.64911. Okay, and it keeps going. Okay, then at the very end, round it now. Okay, so it's 32.65. Now, it was a perimeter. So go back and see what units were given anywhere along the way. So was there any units to do with meters or centimeters or anything like that so far? No. So, oh yeah, give your answer in centimeters. There we go. So that means that my answer here is centimeters. Okay, part E then says each 1 centimeter unit on the coordinate diagram represents an actual distance of 50 meters. The actual area of the park is 150,000 meters squared. Work out the area of the parallelogram in the diagram. Okay, so they have given us each 1 centimetre is 50 metres. So this is just a ratio or a scaling question. Okay, we have 1 centimetre goes to 50 metres. Okay, so 1 centimetre is 50 metres. Okay, it does say then, so it's looking at area, so we're actually having to go to squared units here. Okay, so if I want to go and get a 1 centimetre squared equivalent, okay, I'm going to have to square this to get that, to get 1 centimetre squared there. Okay, which means I then have to square this as well. Okay, to get what it is in terms of metres squared. So when I do that, I'm going to get 2,500 metres squared. Okay, so this is a little bit different to how we'd usually do it. Okay, but now we can see our ratio of how we're getting from 1 centimetre squared to metres squared. Okay, and then we can see, right, well, what does, in centimetres, what does it need to get 150,000 metres squared? So what did I have to multiply that by to get to there? So I would have had to multiply it by 60, which means I'd have to multiply this by 60 as well. So 60 centimetres squared is that area. Okay, another way of doing it, we could have split up this shape into 2 triangles, right angle triangles, and found the area of them, and 1 rectangle. So we could have done it as a compound shape. Or another way we could have done it is use our formula just for the area of a parallelogram straight away. Okay, so that is just the base by the perpendicular height. Okay, so the area of a parallelogram is the base. It has to be the perpendicular height. Okay, so it's going to be, if I use the base of 10 here, just because it's the easier number, it's 10 by its perpendicular height, not the square root of 40, okay, but the perpendicular height, the height perpendicular to 10, which is 6. So 10 times 6, so we get 60. Okay, remember we are looking at it in this diagram where they're representing centimetres, and now it's area, so it's centimetres squared. Okay, and then the last part F, says work out the scale of the map. Give your answer in the form 1 to n. Now, we have been given that 1 centimetre is to 50 metres. Okay, to write a scale, you cannot use this idea of changing the units really. Okay, so what I'm actually going to do is I'm going to say, well, what is 1 centimetre in terms of other centimetres? So how would I write 50 metres in terms of centimetres? Well, if I went from 1 metre to centimetres, I would get 100. So what do I do there? I have multiplied by 100. Okay, so I'm going to do the same thing here. I'm going to say it's 50 times 100, so 5,000. Okay, so then my scale is 1 to 5,000, and we don't need to write units.